A car stops at two sets of traffic lights. On the VT graph up here, we can see those 2 points. Figure 2 shows a graph of the speed of the car as it travels between the two sets of traffic lights. The car takes t seconds to travel between the two sets. We can see that just here. The speed of the car is modelled by the equation v equals 10 take away 0.4t log t plus 1 for times between 0 and t, where t is the time of the car after the car leaves the first set of traffic lights. According to the model, find the value of t. So we have that v is equal to 10 take away 0.4 t, natural log of t plus 1. We have 2 times where v is 0. The first one is given by this part being 0. If t is 0, this bit becomes log 1, which is 0. So the other value over here is going to be when this one is 0. So 10 take away 0.4t is equal to 0. 0.4t is equal to 10. T is going to be 10 divided by 0.4, which is 25. And that one is capital T. So, part B, we want to show that the maximum speed of the car occurs when this expression here is true. So, first thing we're going to need to do is differentiate. So we want dv dt. Now this is a product. So let's say that u is equal to 10 take away 0.4t and that v is equal to log t plus 1. Then du dt is going to be negative 0.4. dv dt is going to be 1 over t plus 1. So dv dt is going to be v du dx, so that's negative 0.4 log t plus 1 plus 10 take away 0.4t divided by t plus 1, and that's the u times dv dt. Now we need dv dt to be equal to 0, which means that we can write 0.4 log t plus 1 is equal to 10 take away 0.4t divided by t plus 1. So we then get 0.4 t plus 1 log t plus 1 is equal to 10 take away 0.4 t. Now, if we divide both sides by 0.4, that gives me t plus 1 log t plus 1 is equal to 25 take away t. Now, if we look at our iterative formula, the t that's inside the log is over here on the right, and the t's that aren't inside the log are over here. So in order to try to isolate the t's not in the log, what I'm going to do is bring this t here over to the same side as this t here and take the log t plus 1 onto the other side. So I've got t ln t plus 1 plus t is equal to 25 take away ln t plus 1. And then on the left hand side we can factorize. t ln t plus 1 plus 1, and that's going to be equal to 25. Take away ln t plus 1. So divide both sides by this. T is equal to 25 over ln t plus 1 plus 1. Take away ln t plus 1 over ln t plus 1 plus 1. So that's 25 over ln t plus 1 plus 1. Take away ln t plus 1 plus 1, take away 1, all over ln t plus 1 plus 1. And that last term there, we can split that. So that is going to be 25 over ln t plus 1 plus 1. Take away ln t plus 1 plus 1 over ln t plus 1 plus 1. And then note with the minus here, we'll get plus 1 over ln t plus 1 plus 1. And we can put this term and this term together because they have the same denominator. So that is going to be 26 over ln t plus 1 plus 1. And then this term here, the top and the bottom are the same. So it's just take away 1. And then we can see that we've arrived at our target expression. So let's move on to the last part of the question. We're starting with t1 is 7. We want to find t3 to 3 decimal places, and then find by repeated iteration the time taken for the car to reach the maximum speed. So we have that tn plus 1 is equal to 26 over 1 plus ln tn plus 1, take away 1. So starting with 7, we can set this up on the calculator. So let's press 7 equals, and then we can set this up as 26 divided by 1 plus the natural log of the last answer plus 1 take away 1. And then T1 was 7, that is T2, that is T3. So to 3 decimal places, T3 is equal to 7.298. And then we just need to repeat the iteration. So we'll just keep doing that until it stops changing, which is around there. And so we can say that T is equal to, it's not big T, is it? T max is equal to 7.333 seconds, which it wanted to 3